в области оказания услуг, Ассоциация поддержки научных исследований рада выступить с организатором данного научно-практического мероприятия. Как известно, мы являемся лидером в области оказания услуг научно-образовательным, научно-исследовательским сообществам, организациям высшего профессионального образования не только в Российской Федерации, но и на территории Содружества независимых государств. Находимся мы территориально в городе Барнауле, в самом сердце Евразии, и имеем широкую партнерскую сеть, работая не только в России и странах СНГ, а также реализуя совместные проекты с научно-исследовательскими институтами в странах Восточной Европы, в Южной Америке, а также в странах Юго-Восточной Азии. Цель нашей работы состоит в том, чтобы укреплять научные связи между учеными из разных стран и представляющих разные континенты, а также интегрировать результаты научно-исследовательской деятельности в мировую систему научного знания. Мы предоставляем профессиональные услуги по организации и проведению научных мероприятий, укрепляем международное сотрудничество между организациями, разрабатываем современные концепции научно-исследовательских проектов, приглашаем известных спикеров и осуществляем организационную поддержку по всем вопросам до, во время и после проведения мероприятия. Мы очень рады, что соорганизаторы выбрали платформу ассоциации как хостинг проводимого мероприятия. И, разумеется, сегодняшняя конференция – это пример яркого сотрудничества между учеными разных стран. Сегодня на конференции будет представлено более 70 докладов по самым актуальным направлениям. Это экологический мониторинг и мелиорация, культивация земель, разумеется, в контексте изменения климата. Отдельно будут рассмотрены гидрологические процессы в речных бассейнах в условиях изменения климата, ну и, разумеется, будут рассмотрены вопросы моделирования экологических и гидрологических процессов с применением GIS-технологии дистанционного зондирования. Действительно, давайте считать нашу конференцию открытой. Я желаю всем участникам, которые будут дальше работать в 4 сессиях, ярких докладов, интересных дискуссий, и надеюсь, что мы еще не раз увидимся на совместных научно-практических мероприятиях. Спасибо.
Спасибо большое, Антон Владиславович. Нам тоже очень приятно сотрудничать с вами, и надеюсь, что в дальнейшем тоже мы будем с вами работать очень тесно. Теперь разрешите представить Уразкелиева Абдулхамида Бахтиёровича, директора научно-исследовательского института ирригации и водных проблем. Абдулхамид Бахтиёрович, вам слово. Абдулхамид Бахтиёрович, вы с нами?
Который был основан в 1925 году как гидротехнический опытно-исследовательский институт, единственный в Средней Азии. За период деятельности институтом было проведено обширные исследования для стран Центральной гидромелиоративной системы и строительств водных объектов. Номер 191 от 8 апреля 2021 года в институте были созданы региональные центры. Это у нас Каракалпакский региональный центр, Бухарский, Наманганский. Потенциал института составляет 54%. В настоящее время в институте большой международными институтами. Это Институт экологии и географии Академии Китайской Народной Республики. Также имеется сотрудничество ПРООН в области строительства, выпускники которых составляют основной коллектив нашего института. Наш институт является крупнейшей акцией в стране. В последние годы учеными института решены научно-технические вопросы, имеющие большое значение для различных отраслей экономики республики. В контексте изменений климата, по прогнозам специалистов, ожидается повышение температуры воздуха, следовательно, ожидается усиление эвапотранспирации, снижение воды. Разработано инновационная технология в период промывки и вегетации хлопчатника. Спасибо за внимание и желаю плодотворной работы секции конференции. Спасибо большое.
Спасибо большое, Абдул Бахтиевич, за приветственное слово. Теперь разрешите представить нашего европейского партнерского вуза. Это Словацкий сельскохозяйственный университет в городе Нитра. Доктор Ян Хорек. Он будет выступать с приветственной речью.
Микрофон, пожалуйста.
You're muted, Dr. Jan Horek.
Janko, nie masz звук.
Okay. Now, can you hear me now?
Yes, we can hear you.
Добре.
Okay, good morning. Let me introduce myself. My name is Jan Horag, and I'm a Vice Dean for Science and Research at the Faculty of Horticulture and Landscape Engineering, which is a part of our Slovak University of Agriculture in town Nitra in Slovakia. It is our great pleasure to take part in organization of this conference, AGEC 2022, under the title Agroecosystems, Land Reclamation and Water Resources in the Context of Climate Change. Thank you very much for all of you for joining this online and face-to-face conference. Just before you get started, I would like to thank to all organizations from Tashkent in Uzbekistan, including all people who are involved in the organization of this conference, also including our colleague, Dr. Kaletova from our faculty. Thank you very much for spending your time, sometimes also the free time in the evenings, to prepare this face-to-face and online meeting. This conference has the topics which are facing the most important issue of nowadays and are very much related to the topic of our university and especially to the topic of our faculty, and it is a climate change, and the climate change is by far the most discussed topic for the entire scientific and normal world. The consequences of climate change are forcing states to reconsider their sustainable development strategies and to work on adaptation and mitigation strategies, preserving the water and soil in a sustainable way. Well, I don't want to talk a lot because this conference floor is yours. Here you can discuss and exchange your latest findings and about the mentioned topics. This conference is also the floor for where you can get each other and exchange experiences and set up the joint collaboration in the future, which is very important for your scientific and also academic future. I mean, a young scientist. I'm sure that you will have a fruitful and rewarding exchanges also with the colleagues from our university and faculty who are also going to present their results of research. I can't also forget to send the greetings from our Dean of our faculty, Professor Dusan Igas, who is also happy that our university is participating in this conference and which is well organized. Thank you very much and have a nice and a fruitful day. Thank you.
Yeah, thank you there, Dr. Jan Horek, for the nice speech, and thank you for the cooperation, for the agreement that you joined this conference as a partner. Thank you. Спасибо за организаторов, за их приветственные слова. Теперь разрешите перейти к пленарной части нашей конференции. И здесь мы выслушаем два доклада от наших словацких ученых, которые согласились презентовать их доклады в пленарной сессии. Спасибо. И первым выступает в пленарной сессии Калетова Татьяна из Словацкого сельскохозяйственного университета в Нитре.
Good morning, everyone. It's nice to see you and to have a presentation for you. Let me share the screen with you and start the presentation. I will talk in English because it's better and easier for me, like in the Russian. So the topic of my presentation is capacity and kinematic structure of water flow in open channels. And it's the part of the results which I get during my research study last year in Tashkent. So a couple of you may remember me and met directly in the Tashkent. At the beginning, what is important to say, because not everyone have all the information how the water is moving in the rivers and channels, and especially in Uzbekistan as well as in Slovakia, you have thousands of kilometers of channels which are used for the irrigation or drainage of the area where it is listed. So when we do the design of channels, the average flow rate of water must have a certain value, and the available water flow rate in the channel should be within the minimum, what is not silting velocity, or the maximum as known as scoring velocity. It means that the water should be in the, or the velocity of the water should be in the limits when the sediments and loads in the water shouldn't be silted, so they shouldn't fall down in the stream, but also the velocity shouldn't be over that it will take more sediments and materials from the banks or from the bottom of the channel, because it can destroy it. Therefore, it is really necessary to have a good or available velocity in the channel, which not destroying the channels as itself. The silting, the problem of the silting is that it decreasing the capacity. So how much water can flow in the channel itself. The scoring velocity damage the channels, especially the banks, and changing the diameters of the channel as itself. What is the problem when we are talking about the velocity and its capacity to deliver the sediments from one point to another, or from one place to another, is the distribution of the velocity. If we take a look on the Y stream, or on the profile of the stream, we can see that a couple of centimeters or percentage, approximately in the 90% of the water depth is the highest velocity when we are talking about open channels, and it's increasing, going to the bottom. But also the similar situation is when we are talking about the transverse velocity or its distribution from the middle of the open channel to the banks. So it's always decreasing, and therefore also usually in these parts we can find the sediments with the decreasing velocity. And therefore the most sediments are silting in that areas. Here we can see that different structures or different soils have different critical velocities. So different silting velocities in which they started to flow, or which they when they started to flow, and if the velocity is higher than this critical one, they are moving in the stream as itself. So the sandy soil or sandy particles usually are start to move about 30 centimeters per second. When we are talking about gravels, the velocity started about 1.2 meter per second. At the beginning, what we have to do, or what we are able to calculate, is the channel capacity, which is usually the most important parameter. So how much water we can deliver by the channel as itself. And in case of uniform flow, usually we use the Shazy-Manning formula, which can be applied very easily, and we need just the parameters of the channel, as is the cross-section area, the water depth, slope of the bottom, and we need the information from which material this channel is made. And after that, we are able to calculate the channel capacity or the discharge, which is in that area. According to hydrometric model, the flow rate in the channel can be determined based on the changes of the water level in that channel. And when we need to describe the kinematic structure of the flow, we need to introduce several changes or several possibilities where we can see how it's changing according to the depth and according to the distance from the banks to the middle of the or center of the channel as itself. There were several scientists who tried to develop the formulation of the flow, because even if we have uniform flow, the distribution is changing, especially in the curves of the channel as itself. And we will see it also in our presentation, or based on our results, that the distribution is not always only the curve as itself, but there can be different possibilities how the distribution of the velocity can be done within the channel. So therefore, we work on these parameters, and at the end we decided that the distribution of the average velocity over the width of the flow on each vertical bit will be written in the form of the velocity or the mean velocity in that distance from the banks, and it will be done based on the mean velocity which was calculated or measured directly in the area based on the standard calculation where we got Q is equal, or the discharge is equal velocity multiplied the cross-section area. So if we know the discharge and the area, we are able to calculate the mean velocity, which we will use to calculate the velocity in different distances from the banks, left bank or right bank. And of course, we will consider in which distance we calculate this velocity, and based on the whole width of the channel in the water level. So we did it on several channels, or we make the analysis on the several channels. I will present the results from the Namagan channel, where we can see there are several different cross sections where the measurements were done. And to do the measurement of the velocity, discharge, and the area, cross-section areas itself was done by the Sontec Doppler current profiler, which is called River Surveyor. Also, they were used or directly measured the parameters by the River Surveyor Live software. And after that, we analyzed the data by the Excel and by the MATLAB software. So based on the results, so we made the analysis of the velocity in the distances with the mean velocity in 1 meter from the bank. So we could see that in that Namagan River, we got the width in the water level approximately 25 meters. So the dots are measured velocities in the distance of 1 meter, so the mean velocity for the whole depth. And after that, we plotted the trend lines for each measurement which were done. So we have the results from the first cross-section area, and they were done 4 different measurements. So it means that the boat went from the left bank to the right bank 4 times. So we have 4 different velocities. 4 different pairs of the measurements, which we analyze at the end. And the method which was used was the best fit trend line was used for the another calculations. So in this case, it was those red dots and red line with the confidence 0.94, what is really high confidence of the results. Based on this formula for the velocity distribution in the channel, we calculated the values, or we create the formula for the values of x as a coefficient, which should describe the values for the distribution of the velocity in the water depth, how it's changing, or it describes those changes. And we try to find if it's possible to find any coefficient which can be used in such cases. So based on the results which we got from the measurements, we prepare such formulas. As we can see, the trend line has also a high confidence, based on which we decided to compare the results in another parts of the channel in Namagan. And here we can see several results which we get from different places. We can see that we have here cross-section 7 with different measurements, and also the cross-section number 2. Those results are the less precise based on the calculations. As we can see that the measured results were higher than results which were calculated or predicted by us and our formulas. And especially if we use the formula based on the previous line, use the X value, we got the triangle, or almost triangle shape of the velocity distribution. If we use just the formula from the previous velocities, so this one y, we got this dash line, which is much more lower velocities than the measured one. In the another values, or another cross-section profiles, the values were a little bit better and describe the situation better. But as we can see it here, one of the problem which was is the distribution of the water, which is not directly as a quadratic curve, but it's more quadratic curve, or like the M later. And therefore it's a little bit more difficult to describe it by the standard value and just one parameter. Also, several others scientists made the analysis, and the first one which was propagated was Snooki, and he has similar values. Also, his results get the curve which was not maybe exactly the letter M, but he has a small peak, as we can see it in this solid line. But the problem was the parameter, and what was changing was only the peak. It was moving to the right or left side. So after that, the Bogle in 1997 create a quadratic formula which was a little bit better than the results of our measurements. But the problem is that he got the negative values of the velocity, was what is of course not normal, and therefore this formula is not very suitable to be used in the practice. And also in 2004, Seo and Beck, they created a new formula which could be more realistic for our results. But the problem is also, as they mentioned directly in their paper, that they need two different coefficients for unknown values, which have to be determined based on the calculation and method trial by error. So it means that you are trying to use one parameter, let's say at the beginning 1, for the another coefficient 2, and you will get the results. You don't like, okay, so you are going to find or to use 1.5 and 1, what's going on, how it will change. So it's time consuming, and therefore there is a problem how to correctly apply it. Also, when we done those measurements for different channels, like the channel in Fergana Valley, and also another one in the Tashkent, in Tash Canal, the problems were the distribution and the width of the channel as itself, because we made the analysis for the width of 25 meters, but also here, as we can see, we have the width about from 12 to 15 meters, and therefore our formula doesn't work very well. When we use the formula for the touch canal, in which we had the width about 30 meters, our predicted values were higher than the real measured values. So that's another problem which we have to consider in our calculations in the future. What is another problem when we are taking a look on these values was that even we had the same channel and between two different profiles which we analyzed, there were no direct water inflow into the channel. The velocities were changing even if we had just the straight channel. And as you can see, those velocities increasing in several places, and usually in the middle, as we can see it on the right side figure, but also on the left side. In the middle, we got lower values, and in these places, the sediment has a possibility to a little bit sit down, but those sediments usually are only the gravels or coarse materials, but around the values are a little bit higher. What we can see, these small arrows show us what is the distribution of the velocities within the channel itself. So we can see that the velocities are moving from the banks to the middle, where it's mixed together the different materials which can be washed out or can flow directly with the river downstream. So if you remember the table from the beginning where I was talking that the gravels are start to move with the velocity 1.2 meter approximately, and 1.2 meter per second. Here we have the values in centimeters per second, which the maximum was about 1,000 centimeters, so 1 meter per second. We can see that really high amount of sediments can be delivered by the water. Also, as we can see, as I mentioned at the beginning, the velocity is changing from the top, from the water level to the bottom. Especially here, we can see that we have this distribution really high in the channels, and therefore, especially in the middle part, we can have the highest values of transported sediments in the channels itself, and they start to silt from the banks to the middle of the area. Really, it depends on the current conditions, and if we have there some construction which can change the distribution of the velocity, because here we can see the standard distribution of the velocity, but here we have in the middle lower velocities because it was changed or confused by the structures which were done in or constructed in the rivers in some places, like the bridge, usually the bridge in the channel, which can decrease or change the profile of the distribution of the water velocities, and therefore also the capacity of distribution of sediments in the channels itself. So that was just the small presentation of the results which we got, and I would like to thank you for your attention, as well as my special thanks are to colleagues from Tashkent who made the analysis and helped me to make these results, and also to Professor Arif Janov, who was the supervisor of my research stay in Uzbekistan. So thanks a lot, and have a nice day.
Thank you, Dr. Tatiana Kalitova, for the informative presentation. Next presentation goes to the Professor Lubos Juric from the same university, the Slovakia University in Nitra. His presentation topic is the protective and retention functions of built drainage systems in Slovakia in the current condition of land use. Your floor is yours, the professor.
Здравствуйте, поздравляю, господин ректор, дорогие участники этой конференции. Для меня очень интересно, что я могу принять участие на выступлении на этой конференции и тоже в этой пленарной части. Я знаю немножко на русском, но не более, и буду продолжать на английском языке. Thank you again for possibility to be one part of your conference. And you can hear earlier some practical presentation. And if we are a little bit older, then we have to solve also theoretical aspects of water management in landscape. And we have to look at not only small problems, but of whole country. And my presentation will be about this possibility that we have to have some wider look at landscape. This month, it will be all over the world some specific day, World Water Day, and for each year we have some specific topic. And this year it's very good topic to your conference there, where that it is groundwater, some resource which we can not see, but we have to look at this groundwater as very important resource in the landscape for people, also for other parts of landscape. My presentation is about drainage constructions in Slovakia, and this construction was used especially in our country to change condition of heavy soils. This heavy soils was not able to be cultivated in the spring, and then you haven't crop from this part of soils. And these constructions was also very important for health of inhabitants. There were in this wet soils was also source of malaria. And then till 1950, we have still in Slovakia also malaria, and after drainage constructions was no more in our country. Drainage was constructed in Slovakia from 1950 to 1990, and from this year we have we can say no more constructions in hydromelioration. And then we have just now in Slovakia something about 6,000 kilometers of open drainage channels as open drainage. And then drainage was constructed at so 400,000 hectares and irrigation at 270,000 hectares. drainage channels was constructed in open landscape.
Profesor, prepáčte, pán profesor, ale nezdieľate obrazovku, zdieľate len prezentáciu, takže neviem, či sa posúvate v nej.
Nevidno moju prezentáciu?
Nie, vidieť len teda tie prvé slajdy, takže ste dali asi zdieľať len prezentáciu, takže lepšie bude, keď už len sa budete v rámci slajdov presúvať.
Pustím to ešte raz.
Dajte zdieľať celú obrazovku, to je lepšie.
Neviem, jak sa to robí, že...
Skúste teraz ešte dať. Alebo len normálne sa presúvajte po slajdoch, ako ich máte teraz.
Dobre.
Ste boli asi na 4. Ďakujem.
Then again, we have in Slovakia so about 6,000 kilometers of drainage channels and 400 kilometers of drainage, landscape drainage. And then we have also possibility to create these channels in an open landscape. But just now, it's changing a little bit situation. These drainage channels, it's a basic role of drainage to keep some underground level of groundwater, what is good for root systems of plants, that you have possibility to bring crop. And in heavy soils in the eastern part of Slovakia was not possible to create underground drainage and was create systems of open channels, as you can see at both pictures. In upper picture, and then you can see from landscape that these channels are creating a network of many kilometers of channels as open drainage system, not underground. If you look at the age of these systems, then only some percent was built before 1960, then from 1950. 1960 to 1970 was built, so about 50%, and then next 50% was built from 1970 to 1990. But after political changes in our space, then we haven't more new construction of drainage, and over the years was drainage without interest of our farmers, and they was not really maintained. And just now it's time that government have to find solution for reconstruction of this drainage system and bring something what will be good to again have a under control groundwater level and also space in landscape. These channels, which was created in 1960, 1970, are just now one part of landscape. They are also surrounding with bushes or trees, and these channels are mostly empty. And from previous designed stage, what was as is picture here in upper part, just now they are fully included to landscape with trees, with bushes, and mostly it's overgrow also vegetation or in some space of these channels. Then we have to find solution for our country, Gerard, that we have from 2022 some state program for remediation of drainage channels. How to do it? If we have to bring back these channels to previous stage as was constructed 60, 70 years ago, or we have to find some compromise between technical solution and landscape and bring these channels only to good solution with good condition with water flow, and they can be again one part of nature. Then we have also some specific problems solved in small ranges, and you can see here is one part where we also this channel cleaned totally to previous stage, but it is not very good look at this system from inhabitants. They will not see more this technical work. That was destroyed trees, this were destroyed landscape, and that's not good. Other part of this drainage system are pumping stations. Water in drainage system was taken to big depth after long way, and then was necessary to pump water from drainage channels to rivers over pumping stations. This pumping station, they need also reconstruction, but we have still good working pumping station. They can be used for future, and they can take away drainage water from some part of drainage systems. Other problem in these channels, it's as was mentioned by previous presentation, that these channels are over the 60-70 years full-filled with sediments, but after our research that these sediments, there are only fine particles. There were water flow in these channels is water speed is really small, and then it's also transportation possibility of particles really small, and then you can find only very fine particles in sediments, and they are not so problematic. It is problem that it's not very good maintenance. Also, some specific object here is object there is outflow from drainage to channel. What is solution after these 60-70 years in drained territories? That this soil is absolutely changed. It was using for crop over 70 years, and structure of these soils, heavy soils, was fulfilled with organic matter. Then it's also very often cultivated. Then structure of these soils, it's really good, and they are more permeable. They are not so problematic, and water is flowing or infiltrated. But all big crops, we are losing groundwater. And groundwater, what was previous years as we start constructed these channels somewhere in depth, so about 60-70 centimeters on the surface. These 60-70 centimeters are just now somewhere in depth 2 meters. And drainage, all these channels are situated somewhere in depth where is no more groundwater, and then it's also structure, also functions of these soils different. And then just now we have more problem that groundwater, it's really depth, and then it's not so helping for crop. And then we have taken for solution one drainage system with one pumping station, and we are looking that you can see soil is really dry in this territory. How can be used this pumping station to bring back water to drainage system? How bring back this water to channels? And these channels can be used for infiltration, that the groundwater will be going back up to good depths, as was in previous years. There were just now it's dry, so about 2 meters of soil. And then you can see here in this upper picture that these pumping stations are connected to rivers, and then it's maybe possibility, if it's higher flow in river, change work of these pumps and bring back water to channels, and over these channels can be water transported as backflow to territory, and then this water can be used for so-called natural or underground irrigation or underground water supply to drained territories. This East Slovakian lowland, it's absolutely lowland. You have in one cadastre, one village, you have elevation difference, maybe 1 meter, then it's not problem with this backflow and pumping water to system. And what is problem? Then you can see at end of the system, it's pumping station, and then you can see that we have here some kilometers of drainage channels, but to some of these channels, it's connected also underground drainage. Then if we bring back water to channels, then this water will be distributed also underground to territory, which is connected with drainage channels. And then we can solve maybe water regime, water balance for wider territories, as is only territory which is near to our channels. Then I am speaking very often with people. They are at Ministry of Agriculture, and we have to bring strategy how to carry for these 6,000 kilometers of Slovak drainage channels, and what will be good solution for next 20-30 years, and how to bring back for use for good operation channel systems in Slovakia. And there it's not only a simple calculation of one point that it's a strategical solution. It's necessary so about 4 million euro for one of some construction, as you can see, and together for Slovakia, it's calculated about 700 million euro will be necessary to bring back to optimal works our drainage system. Basic for this estimation, it's plans which was created by drainage system. We found designer of this system, and we have some pictures where we can solve water level, and we can find maximum water level. It's this yellow part, this picture, how can be developed water level or water regime in this channel. And then we can say that water is flowing also to connected drainage system. And it's only to calculate backflow, how can be water transported in channels which are just now partly with water, partly empty, and how will be how create a regime of pumps to bring back water at distances 6-7 kilometers to landscape. Here is other picture. You can see many of these channels are empty during the year. There were groundwater. It's just now maybe 1.5 or 2 meters under bottom of this channel. Then maybe in other European countries will be these problems the same. There were maintenance of drainage was for 30 years no very well organized, and just now we have changed this problem, and we have to use much better our drainage constructions. Thank you for your attentions.
Thank you, Professor Любас Юрий. Если у кого-то из участников есть вопросы, можете задавать. If you have any questions, you can ask.
You can speak also in Russian language. I can understand, only not so good as you are speaking. Если хотите, можете задавать вопросы на русском языке.
Да, если нет вопросов, спасибо
большое.
Большое спасибо. Спасибо. Теперь разрешите перейти к секционной части нашей конференции. И здесь мы будем рассматривать доклады в 4 секциях. И разрешите представить модераторов этих секций. Первая секция, здесь будут слушаться доклады по тематикам экологический мониторинг деградированных земель, интегрированное управление водными ресурсами и водное хозяйство. Модератором является Радкевич Мария Викторовна, профессор кафедры экологии и управления водными ресурсами университета. И здесь мы выслушаем 15 докладов. Вторая сессия направлена на тематику мелиорации и рекультивации земель в условиях изменения климата. Модератором этой сессии является Бигматов Ильхом Абдраимович, профессор и заведующий кафедрой ирригации и мелиорации ТИМСПА. И здесь мы выслушаем 27 докладов, это большая секция. И секция 3 направлена на гидрологические и гидрогеологические процессы в речных бассейнах в условиях изменения климата. Модератором является Гапаров Фуркат Ахтамович, доктор технических наук, доцент, заведующий кафедрой гидрологии и гидрогеологии ТИМСПА. И здесь у нас включены в эту сессию 20 докладов. И самая последняя секция – это секция направлена на моделирование гидравлических и экологических процессов с применением ГИС-технологий и дистанционного зондирования. И модератором этой секции является Аликджанов Айбек Мухамеджанович, доктор технических наук, профессор, заведующий кафедрой гидравлика и гидроинформатика ТИМСПА. И в эту секцию включены 11 докладов. Желаем плодотворной работы этих секций и всем успехов. И сейчас администраторы будут всех направлять, кто будет принимать участие в какой сессии, они будут вас направлять, и каждая секция может начать свою работу. Спасибо огромное за внимание и за сотрудничество.
Muhiddin aka, assalomu alaykum. Hozir demak o'zbek tilida buni demonstratsiya qilib tushuntirganimdan keyin ishtirokchilarga siz rus tilida yana bir marta tushuntirishingizni iltimos qilib qolaman. Demak, bizda 4 ta sessiya zallari bor. Bular sessiya 1. Mana kim ismi familiyasini yozgan bo'lsa, biriktirildi. Ko'rib turganingizdek 3 ta sessionniy zallar, hozir zallar ochiladi. Bu yerda qo'shilmagan ishtirokchilarni biz ularni qo'shishimiz uchun albatta ismi familiyasini yoniga, misol uchun mana Jahongir Mirzo Qobilov C2 sessiyasida ekanligini bilishimiz uchun bu demak ismi familiyasini yozganligini ko'rishimiz mumkin bo'ladi. Demak, shu yerda har bitta ishtirokchi agar mabodo ismi familiyani yozishga qiynalsa, uni chat orqali ham ma'lum qilsa bo'ladi. Biz buni o'zini zallariga yuboramiz va u yerda o'zini dokladlarini qilishi mumkin bo'ladi.
Здесь наш администратор говорит, что у нас есть вот 4 сессии. Если перед фамилией или перед никнеймом, где вы зашли в Zoom, если поставите вот S1, S2 или S3, S4, и организаторы будут вас включать в определенную сессию, и там можете уже непосредственно делать свои доклады или быть слушателем этих сессий. И было бы хорошо, если бы докладчики отправили свои презентации модераторам. Они будут помогать вам включать ваши презентационные материалы.
Рахмат.
Или можете в чате тоже написать, в какую сессию вы хотите быть направлены, и наши администраторы будут вас направлять. Спасибо за внимание.
Demak, mana zallarni ochdim va demak birin-ketin kim qaysi zaldaligini yuboramiz. Hozir o'sha bizni zallarga qarayotgan ishtirokchilarimiz Bobur aka, Jahongir aka, Elyor aka va demak Jasur akalar, sizlar tayyor bo'lsangizlar mikrofonni yoqib bitta bizga ma'lumot berib yuboringizlar, chunki hozir sizlarni organizator qilib qo'yishimiz kerak bo'ladi.
Eshityapmiz.
Assalomu alaykum. Birinchi seksiya Mirzakalov Jahongir Mirzo, biz tayyormiz. Мы же готовы, вы сможете соединяться на первую секцию.
Jahongir aka, mana sizni yubordim.
Malaka 3-seksiya Jasurman.
Jasur aka, mana sizni sarganizator qilaman hozir. U yerda demak boshlashingiz mumkin bo'ladi. Zapis tugmasi yoddan chiqmasin. Bobur aka, xuddi siz ham siz nechinchi sessiyadan Bobur aka? Bobur aka, siz nechinchi seksiyadan?
To'rt.
Tushunarli.
Xabari bormikan?
Bobur. Demak, hurmatli ishtirokchilar, demak, o'zingizni kompyuteringizdan sessionniy zallar yozuvidan ham foydalanib buni amalga oshirsangiz bo'ladi. Shu yerda chiqib turibdi. O'zingiz xohlagan demak sessionniy zalga o'tishingiz mumkin bo'ladi. Bobur aka, sizni o'tkazdim.
Akmaljon, men qanday kiraman 4-zalga?
4-zalga hozir sizni yuboramiz.
Arifjon.
Bo'ldi. Xo'p, bo'ladi.
Akmaljon, Bakiyev 3-chi.
Bo'ldi. Xo'p, bo'ladi hozir.
Gapporovni istimasidan.
Xo'p, bo'ladi. Hozir mana bitta yuboryapmiz.
Bu yerda bir nechta dokladlar bor kafedramizdan. Muslimov.
Xo'p, bo'ladi ustoz.
Muallim darsda sal kechroq nima keladi. Paxarov bor, u ham demak o'zi qiladi dokladni.
Demak, bo'ldi ustoz, siz o'tyapsiz. 2-sessiya zali sizniki, yo 3-chi?
Meniki 3.
Bo'ldi. Qolganlari ham demak mikrofonni yoqib bitta aytishim mumkin agar mabodo chatga yozish imkoniyati bo'lmasa. Bo'ldi. Siz qaysi sessiyadansiz? Bo'ldi. Hozir sizni 4-ga yuboramiz, a? 3-chi. Bo'ldi, xo'p, 3-chi. Yelena. Bo'ldi. Hozir mana bular yozganlarni yuborib olay. Birinchi, keyin sizga o'tamiz. Muslimov 3-seksiya. Xo'p. Agar kimda yana tushunmovchilik bo'lsa, kim qaysi sessiyaga kirmoqchi bo'lsa, marhamat aytishi mumkin. Muhiddin aka, kechirasiz. xalqaro mehmonlarimizdan bular qaysi seksiyadan?
Участники, которые принимают участие из Российской Федерации, если вы сообщите или напишите в чате, в какую секцию, чтобы вас включили, мы включим вас тоже в соответствующие секции.
Ну.